Okay, so now we're going to continue. I'm going to get rid of this up here. We're going to continue by looking at what we looked at last class, but it got a little bit confusing because I think we started getting goofed as we were moving ourselves around in lines. We're going to look at the traditional, what is called average in a data set. And we started doing this okay, but then it got a little bit weird towards the end. I think we started getting lost about where we were standing because I was moving you all around. The idea of averaging is really about sharing. It's about everybody sharing until everybody in the data set has the same number. So for example, and we'll explain more as we go through this class how to come up with where I start. We're going to take all these people that have fours. Actually, I'm just going to take one of them for starters. We're going to take one person that has a 4, and we're going to pair that with somebody who has a 2. Now, if you think about that, if you think about the people that have 4 and a person that has 2, together they have 6, which means each of them technically could have 3. I know they don't. This one has 4 and this one has 2. But altogether they have 6. So if this one here donates 1 to that one there, then that means they both will have 3. So I'm going to stack them both here. I'm going to also make this transparent. There we go. Which means I can do this. Nope. Oh, that's kind of goofy. Which means I can do this. Okay. Now, I'm also going to clean this up as I go because this is fairly ghetto. And we're going to clean up as we go. All right. Now, think about it. We can do the exact same thing with this person here. And you know what? While we're doing it, we'll do that person, and we'll do this person and this person. Same logic, right? These people have 4. These people have 2. Let's give each one of these 4s one of theirs to these 2s. And that way, everybody has 3. Okay, I'm going to run out of space here, but that's okay because I think we can make it work. Okay, so now we have to do a little bit of thinking now. What if we take this person here with 5? This person here with 5. We can pair that person with one of these people down here with 1, can't we? And if this person gives 2 of theirs to this one becomes a 3, and that 5 becomes a 3. So you see what's happening here? What we end up doing is we end up sharing as we go. And when we share, we end up kind of hovering in on where the most typical data points are going to be. For example, this 8 person right here, we can take that 8 person with 2 of these. Let's make this easier. 1, 2, 3, 4, 5, 6, 7, 8. Watch this. If we take that 8 person and all of these, so we've got 2 1s, a 2, and an 8. If you add up 8 plus 1 plus 1 plus 2, you get 12. And if this 8 person donates a whole bunch of his dots to these other people, for example, this 8 gives 2 to this one, and then 2 to this one, and 1 to this one, he has now given away 5 total of his stands, which means he's left with 3. I don't know why this is not doing transparent. It should be. And then these 2 each got 2 more, which means they're now at 3. And then this one right here. There you go. And now you're starting to see where we're getting at. Now, what makes this data set interesting is that we can continue to do this. It's going to get a little bit ugly now due to this weird little 6 that's right here and these 10s that are right here. Now, we can keep doing this all day long, and I don't want to because the last question I'm going to ask about is what the impact of these 3 out here is. These 3 definitely surprised me, and they may have surprised you as well. But you can see that when you look at the actual original graph, I'm going to drop it in here in a second. Hang on one sec. Let me come over here, copy this, and bring it in here. Here's the original graph. Okay, let's make it bigger so you can see it over top of the other one. Oof. Do you see how there's definitely an area where most of the data clumps, and then there's a weird little tail over here? The data that clumps over here, we just recharacterized into this spike. That spike represents the quote-unquote average of the data. These guys over here are called outliers. So what I'd like you to do for answer 3 for your warm-up is ignore these out here for now. And then you can ignore this you can ignore the 6 as well. That 6 is not going to change very much. Ignore that as well. This spike represents the average if you trim out the outliers of our data set. So answer this as number 3 in your warm-up. And then you can answer number 4 in your warm-up, which is what happens when you put the outliers back in. All right, we'll talk soon.